Okay, so we are on section 6.6, and we are now doing function operations. Okay, you've done these before in Algebra 1. It's just you need to get used to the notation. So if they ask you to do f plus g of x, that means take your f of x function and add it to your g of x function. Easy enough. Same for subtraction, multiplication, and division. But when you do the division, you need to remember to add a little domain restriction, because whatever you have in the bottom cannot equal 0. So you need to make a note and put that g of x cannot equal 0. Everything by equal. Because we can't divide by 0. Right? Dividing by 0 is undefined. So we need to make sure that we are not dividing by 0 when we set up that function f of x that we keep.
Even if we are dividing by 0, you don't know what's wrong, or?
Well, what it would look like is maybe we have x plus 2 over 2x squared minus 8x plus 3. Say it was something like that. And you would just have to say 2x squared minus 8x plus 3 cannot equal 0. That takes care of it. That says, now this function will work everywhere except where that bottom equals 0. So it's just a little bit of notation that you have to put in. Okay? All right. Now, the domain. Because in your homework you'll be asked to find the sum, the difference, the product, the quotient, and then it will say is the domain. So if we look here, it says the domain of the sum, difference, product, and quotient functions consists of the x values that are in the domain of both f and g. Sorry. So if one of them is more restricted than the other, then that's the domain restriction we have to put. And you'll see what that means when we do our example. And then they make the note, the domain of the quotient does not contain any x value that makes g of x equal 0. We do that by just saying g of x cannot equal 0. All right, so let's look at some examples of these. Write this down, please. F of x equals 4x plus 7. And g of x equals root x plus x. What are f plus g and f minus g, and what are their domains? So f plus g is very straightforward. We just take our f of x plus our g of x. Okay. And we write that as a new expression. 4x plus 7 plus root x plus x. We can simplify this just a little bit. What can I combine? My x's, 4x and x. So I see 5x plus 7 plus root x. So we combined our like terms there. Okay, so now we need to look at the domain, and everybody forgets what domain means. Domain means what are the acceptable x values that work in this function. So 4x plus 7, if I graph that, what is it?
Line.
It is a line. Are there any restrictions on the x values we can plug into a line? None. So 4x plus 7, the domain is all real. What about root x plus x? Well, the plus x part can be anything but root x. Can we put anything under a root? No negative. So this one, x has to be greater than or equal to 0. So you choose the more restrictive of the two, and our domain here is that x has to be greater than or equal to 0. Then f minus g, we're going to have 4x plus 7 minus, keep it in parentheses so you remember to distribute the negative, root x plus x. Every time I do subtraction this way, I get rid of my parentheses first, so I have 4x plus 7 minus root x minus x. Again, we can combine our like terms and get what? Subtracting? 3x. Plus 7 minus root x. Tell me about the domain. Same process we did up here, still f and g. So you use the domain from the more restrictive. Yep. So again, we say the domain has to be x is greater than or equal to 0. So to get your domain, just look at the original two functions and pick the more restrictive of the two, the one that limits you more.
And that's just the answer.
So our answer is this, and the domain is x greater than or equal to 0.
Well, why are we simplifying? You can just figure stuff out of the
We're not. We're finding the simplified answer and the domain. We're finding both. So you're finding the f plus g and then its domain, and the f minus g and its domain. Okay? Questions on that one? Okay. So now multiplying, dividing, same type of thing. Just, I will warn you, remember your rules of multiplying polynomials, how you need to distribute these two. All right, so if we want f of x times g of x, let's look at the domains first. What's the domain on x squared minus 9? Is there any number that can't go in and work? No. So when I ask that question, you should be looking for roots. You should be looking for fractions, because at the bottom of a fraction cannot equal 0. What goes in a root cannot be negative. Those are the types of things you look for when you're doing domain restrictions. So this one is all real numbers. And what about that one? The line, so that's all real numbers. No restrictions on the x that can go in. So let's do f times g. X squared minus 9 times x plus 3. So I can do my domain first. What's the domain? All real numbers. How do I multiply these two? Matter? I need to FOIL. So when I FOIL, what am I first give me? X cubed. Outer?
3x squared.
3x squared. Inner?
Negative 9x.
Okay, minus 9x. And last? Negative 27. Do we have any like terms that we can combine? Nope, so just write it out. X cubed plus 3x squared minus 9x minus 27. That is f times g. Questions there? Okay. All right, let's look at f over g. F divided by g, let's take care of our domain first. G is on the bottom. So what is the g function? X plus 3 cannot equal 0. That one we can solve easily. That means x cannot equal what? Negative 3. So our domain is all real numbers, such that x does not equal negative 3. All right, now we can do f over g. F is x squared minus 9 over x plus 3. Can that be simplified at all? Tell me how. Well, why should be on the top? Yes, why? What do I have to do on the top? To be able to divide, we need to factor the top. X minus 3 times x plus 3, all over x plus 3. Then you can see these guys cancel, and we are left with x minus 3. So our solution is x minus 3, and our domain is all real numbers such that x is not equal. Negative. So on the division, you do need to look to see if you can factor and reduce.
You always have to factor.
Sometimes it doesn't factor, but you always have to look to see if you can. All right, that is our division. Any questions before I go out here? Same thing we've been doing with polynomials, it's just they're giving us the notation in different forms. All right, composition. You guys remember composition of functions? All right, it's where you put one function inside another function. Okay? The way that it is written is, so we're going to do our notes first, so I'm going to separate my page a little bit. Put my notes over here. So the way that we write composition of functions is you'll see it as f parentheses g of x, and that is read f of g of x. And the other way they like to write it is f little circle g. Both of those mean f of g of x. There, that's up to you there. Okay, now, when we do this, if they ask you to find g of f written with the little circle, my suggestion is to rewrite it with the parentheses notation, because it's easier to see what's inside. So the first thing I would do, since they are asking us to find g of f of x, and they are asking us about g of f of negative 3, but we are going to find g of f of x first. So the first thing I would do is write g parentheses f of x. So it's easy to see that the f of x is on the inside. All right, well, we start from the inside and work out. So what is f of x? X minus 5. So we are doing g of x minus 5, which means that I write the g function, and instead of writing x, I write x minus 5. So my way of remembering how to do that is I write the g function with a blank where the x is. G is x squared, so I'm going to write that as a big blank squared, and I'm going to put it in the blank. Not x, but x minus 5. So that is g of f of x. And now if I want g of f of negative 3, what do I do? All I need to do is put negative 3 in for x. Giving me what? Negative 3 minus 5. Negative 8 squared.
64.
64. So that is one way you can do g of f of negative 3. Find g of f of x first. And then plug in negative 3. Or, the second way we could do it, g of f of negative 3, we can find f of negative 3 first. F was x minus 5, so that's negative 3 minus 5 equals negative 8. And then plug that into g. And g was x squared, so that's negative 8 squared, which is 64. So two ways you can do it. You can find g of f of x first and then plug in negative 3. Or you can work from the inside with the negative 3. F of negative 3 and plug that into g. Okay? All right, let's get another example of that. So let's say I have p of x equals x squared plus 3, and q of x equals x plus 2. So let's say I first ask you to find p of q of x. They may not write the of x, they may. So p of q, the first thing I want you to do is rewrite that as p of q of x with parentheses. Alright. So, we start on the inside, so we want P of, which is x plus 2. So now I want you to write the P function with a big blank where the x goes. So that's big blank squared plus 3, and what goes in the blank? Nope, it's what's inside here, x plus 2. So we get x squared plus 4x plus 4 plus 3 is x squared plus 4x plus 7. So we always start from the inside, replace q of x with what it's equal to, rewrite the p function with a blank where the x goes, and then what's in the parentheses goes in the blank. Alright, what if I had q of p of 2? Give me one way that we can go about doing this. So Margaret, what would you do to start? So start on the inside, look at the P of 2. Let's find that value. So that means we plug 2 into the P function. So P of 2 equals what? 2 squared plus 3. 4 plus 3 is 7. Now we want Q of that value. So I plug 7 in where? Into the Q function. So I write my big blank. Plus 2, that's the Q function. What goes in the blank? 7. Our answer? 9. Okay? The compositions take a little more practice than the others. Use this video to help, and our homework. Okay. Write that down, please.
Yep.
It's 401, 9 through 43, every other odd. 69 and 72.